So far we learned how to create different agents like code agent, tool calling agent, and vision agents, right? And we also learned how our agents can perform various tasks for us. And we have created only a single agent and observed how that single agent performed the task we assigned, right? But now let's learn what a multi-agent is. So we already learned that multiple agents can work together and share tasks among them, right? For example, let's assume the task as we want to build an AI travel planner that takes a set of stadium locations and enriches them with nearby attractions and travel details. The agent should process the stadiums: MetLife Stadium in New Jersey, Lincoln Financial Field in Pennsylvania, and Gillette Stadium in Massachusetts. And for each stadium, it must determine the geographic coordinates, that is, latitude and longitude, then estimate the passenger flight time to New York City from that stadium location. In addition, the agent should identify one nearby baseball stadium in the same region if one is available. Finally, it should compile all results into a structured itinerary and visualize the stadium locations on a map. So this workflow is a complex multi-step planning problem, and this is perfect for an AI agent to solve, right? But how would we go about doing this? We have two ways. First one is have a single agent attempt all these steps one by one, and the second option is split the job between multiple agents. Let's start with approach one with one agent. That is, let's start with one agent and provide access to tools so the agent can perform the tasks that we assign. And what tools do you think the agent needs in order to perform these tasks? First one is search API to visit different web pages to gather the information present on the website, and then scrape the data that's present on the web pages. Also, tools to plot the map. And we also need a tool for the travel time calculator, right? So we need to provide all these tools to our LLM in order to perform the assigned tasks, okay? So the web search tool is to look up a baseball stadium near each location, and web page reader or browser tool is to click on search results for these locations and scrape the content for specific details. And for the travel time calculator, a custom tool or function to compute flight time or distance between two coordinates for New York and each provided location. Okay? And we also need mapping or plotting library, that is to create a visual mapper. For example, using Plotly or a similar library to plot latitude or longitude points of locations. So once we provide all these tools to our agent, then it will be able to solve the task end to end, right? With this, you understood what we are trying to achieve here. Like I said, we have two options. One is a single agent attempting to do all these tasks, and the other option is splitting the task between two agents, okay? So the first attempt is with a single agent and multiple tools. Before we get started with the code, first we need to get the API keys for small agents, SERP API and SERPer API. We have already seen how to get the API key for small agents in the previous lectures. Now let's learn how to get the API keys for SERP API and SERPer API. So we need the SERP API key for Google search. Let me take you to the SERP API website. You can see here SERP API is Google search API, and it can scrape Google and other search engines. Okay, so click on sign in on the top right hand corner. You can sign in with your Google Gmail, or you can use GitHub too. Once you log in, click on API key on the left hand side, then copy your private API key, and the other one, we also need the SERPer API key. Let me take you to the SERPer Dev website. You can see the SERPer Dev is the world's fastest and cheapest Google search API, and you get 2,500 free queries, no credit card required, okay? Click on sign up and create an account. Then verify your account. It's pretty straightforward. Once you create an account, log into the SERPer Dev, click on API keys, click on create new key, give any name here, click on create, then copy the SERPer API key, okay? So far we understood our project's task, that is what we are trying to achieve with our agent, and then we got the API keys for SERP API as well as SERPer API. Now let's get started with the code. I'm using Google Colab, but you can use any source code editor, okay? First step, we are installing the required packages with the pip install command. GeoPandas, Shapely and Kaleido are packages for plotting the locations on a map, okay? And we already know small agents and is the service provider through which we can access multiple LLMs. So small agents for AI agent logic, Plotly plus Kaleido for visualization plus export, GeoPandas plus Shapely for geospatial data handling. These are the packages we need to install. Click on the run button to run the cell. And then the next step is we are trying to log in to the Hugging Face Hub to have access to the inference API. Make sure you get the Hugging Face API key and store it in the secret key. Okay, I have already shown you how to get the Hugging Face API key in the previous lectures, right? So once you run this cell, you are successfully logged into Hugging Face and you should be able to use the models from Hugging Face. Now let's create a custom tool. In the previous lectures, we have used predefined libraries as the tools. But now let's create a custom tool. So we are importing math functions and typing helpers, then importing tool decorator for agent usage. We define the function as an AI agent tool using the tool decorator. Then we define the function calculate cargo travel time to compute cargo flight time. And our function inputs are origin, destination, and speed. This is just the function documentation, right? And the helper function to underscore radians is to convert degrees to radians. Here we are converting coordinates to radians. Then we are setting Earth's radius in kilometers and computing coordinate differences. Here we are applying the Haversine formula. We use this because Earth is curved, not flat, right? Then we are computing the great circle distance. And to adjust distance, we are adding a 10% buffer for non-direct routes and air traffic controls. Okay. Then calculate flight time. Here, rounding result to 2 decimal places. This is just an example function call to test if it's working. Okay. So in short, this function defines a custom AI tool that can estimate flight time between 2 geographic points using the Haversine formula and a simple flight speed model, and then tests it with an example route. We already learned that tools are functions which we will provide to our agent in order for the agent to perform an action, right? Then let's define the model to provide that to our agent. So we initialize the Quen model. So small agents is the agentic framework and it controls tools as well as workflow. Inference client model is the connector to an external LLM like Quen. Okay. And then we define the task as use the stadium's MetLife, Lincoln Financial Field, Gillette Stadium, and for each stadium get its latitude and longitude and calculate flight time from New York City using a passenger plane. And depending on your location, you need to update the latitude and longitude values here, okay? Then find one nearby baseball stadium in the same region if available. Return only a pandas data frame with the columns, stadium name, latitude, longitude, travel time to New York, and nearby baseball stadium. And do not include explanations, only return the data frame. So this is how we defined our task. And you can change this prompt depending on your requirement, okay? So this is the task we want our agent to perform. Here we are setting the SERP API key for Google search and then create a small agent's code agent. Provide agent access to model tools for the Google search tool. Instead of SERP API, you can use DuckDuckGo search tool as well if you want. Also notice we are using the custom tool that we created. Okay. So Google search tool is to search a web page. Visit web page tool is go to that web page, gather the information present on the website. Both Google search tool and visit web page tool are provided by small agents itself. If you see the imports on the top. Okay. And with this line, we want to return the result as a pandas data frame. So now you can see the advantage of using code agents over tool calling agents, right? Code agents formulate the action as code. So adding this pandas will make the agent use the Python pandas library code easily. Okay. And then we are running the agent by calling the run method and we are passing the task as well. Make sure you run all the cells and don't forget to set your API keys everywhere, right? Now let's see the execution logs. Okay. You can see everything has been formulated as code as we are using code agent, right? And if you scroll down the execution log, you can see our code agent is using our custom function. Okay. And if you scroll down the execution log, it integrated pandas data frame as well. Okay. And finally, the agent is satisfied with the answer and gave us the final answer. It gave the nearby baseball stadiums along with the travel time to New York as a data frame, right? If you look at the result, this is the pandas data frame. You can see the nearby baseball stadiums as well as the time it takes to travel. So our code agent was able to get the results for us. Behind the scenes, it searched for a list of baseball stadiums, clicked the relevant web page like Wikipedia, and started compiling results. But there are a few issues here. The first one is long context and high token usage because the agent's prompt grew very large and it had to remember all details about stadiums and perform calculations. So the step-by-step reasoning plus intermediate web content was increasing the context, right? And a single agent carrying all this knowledge in one conversation can run out of space or tokens, and this can make it slow and costly. And the second problem is complex reasoning in one brain. That is, the single agent had to juggle web browsing, data extraction, calculations, and mapping logic all in one sequence. And this is cognitively demanding even for an AI and increases the chance of error or the agent losing track of the goal. Okay. So in our run, the single agent got some of the way, but struggled to efficiently finish the task within a reasonable token limit. You can see the travel time is off, right? This is a classic sign that we should refactor the problem. Just like breaking a big program into functions, we can break an agent's job into multiple specialist agents, right? And after you run this code, if you think the agent is not returning the results that you are expecting, then you can try changing the instructions or prompts, okay? And we want our agent to go through an extra number of planning intervals to get the results we want. You can change the interval and experiment and see how many intervals you want to see the desired output. That is, number of intervals equals number of thought action observation loops. Okay. So with these changes, if you scroll down the execution log, okay, we can see the improvement in the agent's response. Okay. If we compare the agent's response with prior output, that is after providing the planning interval and providing the detailed prompt, we can see a better response, right? You can see the results are more accurate now. But the issue here is the context window is quickly filling up. So if we ask our agent to combine the results of a detailed search with another, it will be slower and quickly ramp up tokens and costs, right? So we need to improve the structure of our system. So far we implemented it with one agent by providing different tool access to our agent, right? This is fine, but if we want to improve this code further, we need to use multiple agents. Okay. So far we have only one agent, and that one agent is accessing a web search tool, travel time tool. And in addition to that, we want our code agent to use a plotting tool to plot the locations on the map as well, right? So with one agent, we need to provide these three tools access. We already provided web search tool and travel time tool access to our agent. And we need to provide plotting tool access to our agent so it can plot the locations. This is one way of doing it. And the second way is, let's call our one agent as web agent, which has access to search tool as well as travel time tool. And the manager agent will have access to plotting tool and also access to web agent. With one agent performing all these tasks, then the context of this task will be mentioned as one big prompt. So the amount of attention the one agent can give to each of these tasks, that is web search or travel time or plotting, is divided. So the agent may not be able to perform well, like one person doing multiple tasks, right? Instead, if we divide the tasks among multiple agents, each agent can work as a specialized agent that can perform a specific task instead of one agent doing all the tasks. So the manager agent supervises the web agent and also has access to plotting tools. So with multi-agent systems, where multiple agents work together to achieve a common goal, each agent can be specialized for a subtask or role, and they communicate and coordinate like an AI team. It's like teamwork, right? So before we implement the code, first let's understand the advantages of multi-agents. So multi-agent structures allow us to separate memories between different subtasks with great benefits. The first one is divide and conquer. That is, each agent is more focused on its core task. So the agent can perform better. That is, each agent focuses on a specific task or single responsibility that simplifies complex problems by breaking them into parts. And the next one is parallelism and speed. Agents can work either sequentially or in parallel with less overhead, so they can complete tasks faster. And improved focus and memory. Separating memories reduces the count of input tokens at each step, which will reduce latency and cost. Because if one agent is performing all the tasks, then it consumes more memory, right? And whatever the response we get from one thought action observation loop will be appended to the agent memory. And if we have more loops, it consumes more tokens to complete the task, right? Also, if more information is stuffed into the memory, it will start losing the context, right? Then the LLM may hallucinate and may produce random information. So that's why when we have multiple agents as manager agent, web agent, then each agent will have its own memory, its own LLM, and can perform its task. Okay, they don't interfere with each other. So the agent can produce accurate results, reducing the hallucination. So each agent has its own context or memory. The overall system doesn't need to stuff all information into one prompt. This reduces the prompt size per agent and avoids blowing out the context window, which cuts down on latency and cost, right? Also, fault tolerance. Let's say if one agent gets stuck or doesn't produce the expected result, another agent can catch the issue or request a retry. Okay? And specialization. You can assign different skill sets to different agents such as researcher, calculator, planner, etc. So each uses the best tool or model for its job. So basically we are dividing the tasks across multiple agents for better performance. That is, multi-agent systems bring a sense of teamwork to AI agents. Okay. Now let's create a team with a dedicated web search agent managed by another agent. The manager agent should have plotting capabilities to create its final report. So let us give it access to additional imports, including Plotly and GeoPandas plus Shapely for spatial plotting. Okay, so we created two agents with a clear division of labor. The browser agent or web agent is a specialist responsible for all web searching and reading. This agent's job is to find the information we need, that is nearby stadiums, and return it in a structured format. It has access to internet tools, the search API and web page reader, plus the travel time calculator. It does not worry about making the final report or map. It only gathers raw data. Okay. And the manager agent, a higher level agent that acts as the project manager and finalizer. The manager delegates the information gathering work to the browser agent, waits for the results, then takes those results and performs the remaining tasks. For example, generating the map and compiling the final answer. We gave this manager agent access to the plotting libraries such as Plotly, GeoPandas, etc. and also a strong LLM. That is, we used a GPT-4 level model via an API to do the heavy lifting of analysis and output generation, right? Now, how do these two agents interact? The manager agent essentially calls the browser agent as a tool whenever it needs web data. In our code, this was done by listing the browser agent under managed_agents for the manager. So the manager can issue a subtask like, hey web agent, search for all nearby stadiums, then give me the data, right? The browser agent will execute that request using its search and browse tools and return, say, a list of locations with their coordinates, flight times, and stadium information. Okay. The manager then takes that data and proceeds to produce the map and itinerary. So first let's define our web agent, that is code agent. And the tools that we are providing to our agent are Google search tool from Serper and also the custom tool that we created, calculate cargo travel time to find the distance between two places. And maximum number of steps agents can go through the thought action observation loop are limited to 10. You can change the number according to the results you get. Okay. Here we are using Together provider, but we have other providers too like Sambonova, Block Forest Labs, etc. And for the model, we are using Quen model. So this is how we defined our web agent. Next, the manager agent will need to do some mental heavy lifting. So we give it the stronger model, OpenAI model, GPT-4o, okay, and add a planning underscore interval to the mix. Okay. For our manager agent, which is again a code agent, we are providing tool access, that is calculate cargo travel time. And it has managed underscore agents, which is the web agent. That is the manager agent manages the web agent. Okay. And this manager agent needs to plot as well. Because our manager agent is a code agent, we can directly provide any Python packages to use. So that is one of the advantages of using code agent. It's so easy to integrate any coding package. right? We are calling check reasoning and plot, and this is the prompt we are providing to make sure it is generating the correct map. You can change this prompt and play around, okay? Also, we are saving the file to saved_map.png, okay? And then we can visualize what the manager agent looks like. So let us inspect what this team looks like. So here the manager agent is a code agent and is managing another agent, which is nothing but the web agent. So this is the sub agent which it is managing. Web agent uses Quen as its LLM. Manager agent uses GPT-4o. Manager agent has calculate cargo travel time and final answer. That is the moment when the agent stops executing as tools. Okay, and the web agent, which is the managed agent, which has access to web search, visit web page, calculate cargo travel time, and final answer tools, right? Next, let's run our manager agent. You can see the manager agent's task. If we notice here, we have given an example to our agent. This is nothing but few short prompting. So the agent understands the task better and is able to give us accurate results. That's why we provided an example. If you see the execution log, okay, you can see the agent is thinking and making plans just like a human, right? Okay. If we run this, we can see the plot as well. If we zoom into the figure, you can see the locations that the LLM mapped for us, right? This separation of memory and duties was a game changer. Each agent now has a much more focused context. The browser agent only keeps the web search results and related info in its context. Once it's done and hands off the data, the manager doesn't need the browser agent's entire reasoning history. It just needs the results, right? The manager agent starts with a high-level view and finalizes the output. It doesn't need to internally store how the web search was done, which keeps its prompt concise, right? With the multi-agent approach, we get better performance, and that is each agent is specialized and efficient at its task and lower token usage per step. That is each agent's prompt is smaller, reducing cost and latency. So that's how we were able to improve the efficiency by using multiple agents instead of one agent. Okay.